many years, NASA has done biology experiments in space, creating a huge collection of knowledge for future missions. But most of this data stayed locked in massive archives, hard for people to access or understand. This year, NASA challenged innovators worldwide to build a space biology knowledge engine, a tool that transforms raw data into clear insights. We are Team Falcon, a mix of software engineering students and environmental science students. The environmental science team handled data collection and cross-checking, while the software engineers built the platform. Our mission was clear, not just to make a dashboard but to build a bridge between NASA's groundbreaking research and the explorers of tomorrow. Before AI could work, we first needed the best fuel, authentic NASA's data, so we followed a careful and step-by-step plan. We went straight NASA's planetary data system. For Mars, we used data from the Curiosity rover, InSight lander and Mars Reconnaissance orbiter. For the Moon, we included diviner's temperature data, Lola's topology, and even the Apollo missions archives. In total, more than 5,800 data points. Our team validated everything, cross-checking between missions, running accuracy tests, and ranking dataset by reliability. Tier 1 meant direct measurements, the most trusted and highest quality data. And the amazing thing is, none of the data was AI generated. Every single point comes from NASA's real missions and real measurements. With clean and trusted NASA's data, we built the heart of our project, the BioSphere-X AI engine. It features two completely separate dashboards, one for Mars and one for the moons. They work differently and independently, with no direct relation between them. The first AI model uses reinforcement learning to study complex conditions like temperature, radiation, and soil chemistry and predicts whether an environment can support life. The second model focuses on microorganisms. It predicts which species might survive, such as radiation resistance, the Enococcus on the moon, or cold-loving Psychrobacter on Mars. And to make exploration easy, we built a chatbot that uses natural question and provides answers directly backed by NASA's data. Our platform comes with two integrated dashboards. Here's the Mars dashboard, built from more than 2,500 validated data points. With one click, AI processes calculates environment, temperature, radiation, and soil chemistry, and returns a habitability score with confidence level. You can view real data alongside AI predicts, revealing seasonal trends on Mars. Ask the chatbot to compare the Z0 crater with the North Polar region, and it generates a clear comparison directly from NASA's datasets. The same process applies to Moon dashboard. We can study shadowed craters in South Pole Aitken Basin, checking for possible ice deposits and testing habitability. BioSphere-X makes NASA's biology data simple and useful. We have transformed a raw number into a knowledge engine that speeds up research, support mission planning. It can help missions planner pick landing sites, help scientists design life support systems, and inspire the next explorers. We thank NASA for this challenge and for making their data open to the world. We are Team Falcon. Thank you for watching. Together we are building the tool for humanity's future space.